Hey everyone, and welcome back to the channel. We're your AI experts, and we're here to break down another fascinating topic in electronics.
We might even make some weird sounds along the way.
Exactly. It wouldn't be an electronics channel without a few sparks flying. Today we're going to be talking about voltage.
It's really the foundation.
Yeah, you have to understand voltage if you want to understand how electronics work.
Absolutely.
So,
Yeah.
let's start with the basics.
Okay.
What actually is voltage? Can you explain that in a way that even someone who's never touched a circuit board can grasp?
Absolutely. In the simplest terms, voltage is the difference in electrical potential energy between 2 points.
Okay.
Think of it like water pressure in a pipe.
Okay, I'm picturing a pipe now.
Good. Now imagine one end of the pipe has much higher pressure than the other.
Okay.
That difference in pressure is what makes the water flow voltage, is like that pressure difference, but instead of water, it's pushing electrons through a circuit.
So voltage is kind of like the oomph behind the flow of electricity.
Exactly. The greater the voltage, the greater that potential energy difference, and the stronger the push on those electrons.
That makes sense. But here's where I get a little tripped up.
Okay.
If voltage is just potential energy, does that mean a battery just sitting there and not connected to anything has no voltage?
That's a really insightful question. You're right, voltage is always relative.
Okay.
It's about the potential difference between 2 points.
Right.
A battery does have stored energy, but we only measure voltage when it's connected in a circuit, creating that difference.
Ah, okay, so it needs that complete path
Exactly.
to have a measurable voltage. It's like if you cut that water pipe, the flow would stop.
Exactly. That circuit concept is key.
Okay.
And speaking of key concepts, we can't talk about voltage without mentioning its unit of measurement, the volt,
Right.
named after Alessandro Volta.
Right. I've definitely heard of volts,
Of course.
but why is volta so important?
Well, back in the late 1700s, he invented the voltaic pile, which was essentially the first electric battery. It was a huge breakthrough because it was the first time someone had created a sustained flow of electric current.
Wow. So Volta didn't just give his name to the unit, he practically invented the concept of a battery as we know it.
Pretty much. His work laid the foundation for our entire understanding of electricity and how we can harness it.
That's incredible. So we've got this idea of electrical pressure pushing electrons through a circuit.
Right.
But I have to admit, I still have a fuzzy picture in my head.
Okay.
Is there a way to kind of visualize this push?
There is. Remember how I said voltage is a scalar quantity?
Uh-huh.
That means it has only magnitude, no direction.
Right.
But the actual force pushing those electrons, that's represented by something called the electric field, and that is a vector quantity,
Okay.
meaning it has both magnitude and direction.
Wait, hold on.
Yeah,
Scalar vector. Can you break that down a bit more?
of course. Imagine an arrow.
Okay.
That arrow represents the electric field, with its length being the magnitude or strength of the field, and the direction the arrow is pointing being, well, the direction of the force.
Right.
Voltage is only concerned with the length of that arrow, how much potential energy difference there is.
So voltage is like saying this much force, and the electric field is saying this much force in this direction.
You got it. That's a great way to think about it.
Okay, I think that analogy finally clicked for me. But we've been talking a lot about the theory of voltage.
Right.
Where does this actually come into play in the real world?
Oh, voltage is everywhere in our electronic world. It's the force that drives current through every circuit, from the tiny ones in your smartphone to the massive ones in power grids.
So something as small as my phone uses the same basic principle as a giant power line.
Exactly. Though the scale is obviously very different. Your phone battery might operate at a few volts, while power lines can carry hundreds of thousands of volts.
That is a huge difference. It's amazing how such a vast range of voltages can be utilized. But it makes me wonder, how do we even measure those different levels of voltage? I mean, it's not like we can just slap a ruler on it.
You're right, we need specialized tools for that.
Yeah.
And luckily, there are several instruments designed specifically for measuring voltage,
Okay.
like voltmeters, potentiometers, and oscilloscopes.
Okay, so we've got different tools for measuring voltage, but how do they actually work? What's going on inside those gadgets?
Well, each instrument has its own mechanism, but let's start with the common one you've probably heard of, the voltmeter.
I've definitely heard of those. Are they like little detectives for electricity?
Kind of. They essentially measure the current flowing through a fixed resistor.
Okay.
Remember Ohm's law?
Vaguely something about voltage, current, and resistance being related.
Yes. Ohm's law states that the voltage across a resistor is proportional to the current passing through it.
Right.
So by measuring the current, the voltmeter can calculate the voltage.
Ah, that's clever. So it's not directly measuring voltage, but using current as a clue to figure it out.
Precisely. It's a bit like measuring the speed of a river by observing how fast a leaf is carried downstream.
Yeah.
You're not directly measuring the speed of the water itself, but you can infer it from the movement of something within the flow.
That's a great analogy. So besides the trusty voltmeter, you mentioned other tools for measuring voltage. What about those potentiometers you mentioned earlier? How do those work?
Potentiometers are a bit different. They're actually variable resistors, and they're used to measure voltage by comparing it to a known voltage. It's a bit like using a balance scale to find the weight of an unknown object by comparing it to a set of known weights.
So it's like a voltage balancing act. That's pretty neat. And what about those oscilloscopes? What makes them different from voltmeters and potentiometers?
Oscilloscopes are like the super sleuths of the voltage world. They can measure not just the magnitude of the voltage, but also how it changes over time. They give you a visual representation of the voltage signal, which is incredibly valuable for analyzing complex electronic systems.
So they're like voltmeters, but with a time machine built in.
Haha, in a way, yes.
That's amazing, and I'm guessing that level of detail is crucial for understanding how things like computers and smartphones work.
Absolutely. It's impossible to overstate the importance of oscilloscopes in modern electronics. They're essential for designing, testing, and troubleshooting just about any electronic device you can think of.
But you know what? I'm actually finding it quite fascinating. It's like peeling back the layers of an onion, revealing more and more complexity with each step.
I'm glad you're enjoying the journey. And trust me, we're just getting started. There's so much more to explore about voltage and its role in electronics. But maybe we should take a quick break here and come back to it in our next segment. What do you think?
That sounds like a great idea. Let's give our viewers a chance to digest all this awesome information. We'll be back soon with even more insights into the amazing world of voltage.
Welcome back. So now that we've laid the groundwork, let's explore how voltage shapes the technology we use every day.
I'm ready to see this invisible force in action.
Perfect. Let's start with a classic example. A simple circuit with a battery and a light bulb. The battery provides the voltage, creating that potential difference that pushes electrons through the circuit.
So the battery is like our water pump providing the pressure.
Exactly. And as electrons flow through the filament of the light bulb, their energy is converted into light and heat. That's what makes the bulb glow.
It's fascinating to think that something invisible like voltage is responsible for something as tangible as light.
Isn't it? And by controlling the voltage, we can control the amount of current flowing through the circuit. More voltage means more current and a brighter bulb.
So if I wanted to dim the light, I'd need to lower the voltage.
Exactly. Of course, there are limits. If the voltage is too high, it can overwhelm the circuit and cause damage.
Right.
Just like too much water pressure can burst a pipe.
Yeah, that makes sense.
That's why electronic devices have specific voltage ratings.
Okay, that makes sense. But let's move beyond simple circuits.
Okay.
How does voltage work in something much more complex like a computer?
Well, a computer has numerous circuits, each with its own voltage requirements.
Okay.
The power supply converts the AC voltage from your wall outlet into various DC voltages needed by different components.
So it's like the power supply is a voltage translator, ensuring each part of the computer gets the right amount of electrical push.
That's a great way to put it. And inside the computer, you have millions, even billions of transistors,
Wow.
acting as tiny switches, controlling the flow of current based on the voltage signals they receive.
It's mind-boggling to think that all this intricate stuff, powered by carefully controlled voltage, allows us to do everything from writing code to watching videos.
It is remarkable, and the way those transistors use voltage to represent information is particularly fascinating. They operate using a binary system, ones and zeros,
Right.
where different voltage levels correspond to either a 1 or a 0.
Wait, so those tiny voltage fluctuations are actually encoding data. That's how computers think.
Exactly. The entire digital world, everything from your photos to your music to this video we're making right now,
Wow.
ultimately boils down to patterns of voltage being interpreted as ones and zeros.
That's blowing my mind a little bit.
Yeah.
So voltage isn't just about powering devices.
Right.
It's the language of the digital age.
It really is, and it goes beyond computers. Think about medical devices like electrocardiograms, EKGs, or electroencephalograms, EEGs.
Right. Those measure electrical activity in the heart and brain, don't they?
Yes. They use sensors to detect tiny voltage differences on the skin, which correspond to the electrical signals produced by those organs. Doctors can then use these voltage readings to diagnose and monitor various conditions.
So voltage is literally helping us understand the electrical signals within our own bodies.
Yeah,
That's incredible.
it is. And it's not just medicine. Voltage plays a vital role in scientific research, too. From powering particle accelerators that unlock the secrets of the universe to controlling the movement of ions in mass spectrometers that help us analyze the composition of materials, voltage is everywhere.
It sounds like voltage is one of those fundamental forces like gravity that shapes the world around us in ways we don't always realize. It's incredible how something that started with rubbing amber on fur thousands of years ago has led to such profound advancements.
You're absolutely right, and just imagine what the future holds as our understanding of voltage continues to evolve. We're on the cusp of new breakthroughs in areas like energy storage, quantum computing, and bioelectronics, all driven by this invisible force.
It's truly exciting to think about all the possibilities, but I think we've packed a lot into this segment. Why don't we take another quick pause here?
That sounds good.
Welcome back to the final part of our exploration into the world of voltage.
We've covered a lot of ground.
Yeah, from the basics to some pretty mind-blowing applications.
Absolutely.
It's amazing to think how much we rely on something we can't even see.
Right, it's this invisible force shaping our technological world, driving everything from the simplest circuits to the most complex systems.
You know, it's funny to think that all this amazing technology stems from something as basic as rubbing a balloon on your hair.
That's a great point. Static electricity, the kind you get from that balloon trick, is essentially a buildup of electric potential or voltage.
So even something as simple as sticking a balloon to a wall can teach us about the fundamentals of electricity.
Absolutely. It's a reminder that science is everywhere, even in the most mundane things.
Okay, before we wrap up, I have one more question for you.
Okay.
Are there any common misconceptions about voltage that you've come across?
Oh, definitely. One of the biggest ones is that a higher voltage is always more dangerous.
That's interesting. I always assumed more volts meant more danger.
It's a natural assumption, but it's not entirely accurate. High voltages can certainly be hazardous. It's actually the current that flows through the body that causes harm.
So it's not just the voltage itself, but the combination of voltage and current that determines the risk.
Precisely. A high voltage with very low current might not be dangerous at all, while a lower voltage with high current could be deadly.
That's a really important distinction. It's like the water pipe analogy again. A high-pressure pipe with a tiny opening might not deliver much water, while a lower-pressure pipe with a large opening could unleash a torrent.
Exactly. It's a good reminder that context matters. We need to consider both voltage and current when evaluating electrical safety.
Well, this has been an incredibly insightful conversation. I feel like I've gained a whole new appreciation for voltage and its role in our world.
Me too. It's always fascinating to delve into these fundamental concepts and see how they connect to everything around us.
To all our viewers out there, we hope you found this discussion as engaging as we did. If you have any questions about voltage or any other electronics topic, feel free to leave them in the comments below. And if you enjoyed this video, please give it a thumbs up and subscribe to our channel for more exciting explorations into the world of electronics.
We appreciate your support and look forward to exploring more fascinating topics with you in the future.
Until next time, stay curious and keep those electrons flowing.